Hello everyone, welcome back to another video of Wise Interactive Learning. In this video, we are going to go through the Ncert book and specifically 5.1 exercises. So we'll take the sixth problem. So we can say that f of x is 2x plus 3 till 2. So from minus infinity till 2, it is 2x plus 3, and beyond 2, it is 2x minus 3. So how can we check? So when we plug in 2 over here, this has to be equal to this function, which is f of 2 should be equals to limit x tends to 2 f of x, right? And this should be equal for each and every example which is given over here. So we'll check it. So when we plug in 2, what will happen? It will become 2 into 2, which is 4, plus 3, so 7. And what will this value become? It will become 4. So when you plug in 2, so 7 is not equal to 4. So what we can say is this function is discontinuous. Now coming on to this seventh question. So literally we are going this fast, so we have understood. So in case you don't understand what is the procedure, please make sure that you hit the I button and you can find out how to check the continuity. When you clear up the concepts, you'll find out how easy it is to solve the questions. Now we'll see the seventh question. So it says that till minus 3 these two functions are applied. Since we have a common continuity limit, we have over here. So when you plug in minus 3 over here, the modulus will be the positive value. So it will be minus 3 of mod, which is 3 plus 3, which comes out to be 6. And here you have to plug in minus 3. So minus 2 times minus 3 is equals to 6. So these two are equal. So we can say that this function is continuous. Now we'll look on to the eighth problem, which is mod of x upon x. So of any value of x, if you take it when it is not equals to 0, there will be two conditions. Well, what are those two conditions? Let's say that these values are either positive or negative. So let's say if the positive value is plus 5 and the negative value is minus 5. So if you plug in plus 5, you will get x upon x, which is plus 5 upon plus 5, it will be 1. But in case of negative value, it will become minus 1. Why? Because the numerator will be positive and the denominator will be negative. So this will become negative, minus 1. So you have two different values, and what we can say is at exactly 0, we don't have a defined value at 0. So we can say that this function is discontinuous. Now we'll look on to the ninth problem, which is same, but in this case the x is necessarily and strictly negative. Why? Because it is less than 0. So the numerator, since this value is a negative value, it will be negative, but the denominator will be positive, and this value will be x upon x. So let's say the negative value we can take again as minus 5. So minus 5 upon mod of minus 5, this will become minus 1, and which we have exactly at f equals to f of 0. So limit x tends to 0 f of x. So these two are equal. So we can say that this function is continuous. Now we'll check the 10th problem. So 10th problem is very easy. So you just have to plug in 1 over here. So 1 plus 1 is equals to 2. And when you plug again 1 over here, what you have? 1 square plus 1, which is again 2. So I don't think so this question should be in textbook also. It is that easy. So now we'll check the 11th problem. So here the continuity limit is 2. So you have to plug in 2 over here. So 2 cube will be 8. 8 minus 3 is 5. So the value of this function is 5. And what is value over here? 2 squared is 4 plus 1 is again 5. So you can say that these two values are equal. So this function is continuous. So the 12th question is x raised to 10 minus 1 till the value is x is equals to or less than strictly 1. So if you plug in the values over here, what will become? 1 raised to 10 minus 1. So still 1 raised to 10 is 1. So this value is 0. And when you plug in 1, we have 1 squared as 1. So you can see that these two are not equal. So you can say that this function is discontinuous. Okay, now we have taken a different kind of problems which are basically finding the relationship or finding the exact value of any a, b or lambda types of values. So we'll take a look, which is the 17th and the 18th problem. So 17th problem says that find the relationship in between a and b if the function of f of x is continuous at x equals to 3. So what it necessarily tells us that at f of 3 it is equals to limit x tends to 3 f of x. So this is already given, we don't have to find out this. Okay, so now we have to do the reverse procedure. So what we have to find is, we have to find this a and b value. So we know that these two are different, equal, so f of 3 will be what? So you have to plug in 3 over at the x value, so it will be a times 3 plus 1, which is equal to, since we are equal, so we have to again plug in 3 over here, which is b times 3 plus 3. So it's that simple. So now you just have to take simplification. So we can say that a times 3 is equals to b times 3 plus 2, since we have subtracted 1 from both the sides, and then divide by 3 on both sides. So a equals to, so when you divide this by 3 you get b plus 2 upon 3. So this is your answer. Now we'll look on to the 18th problem, which is also easy. What it says that for what value of lambda, which is lambda over here, what value of lambda is the function continuous? So in order to find the function to be continuous at 0, we need f of 0 equals to limit x tends to 0 f of x, right? So f of x is over here, since it is not equals to 0. So what will be f of 0? First we need to find out that. It will be lambda times x square. So what is x? X is 0. 0 square minus 2 times 0. Well, what will be this? So it will be lambda times 0, right? So no matter what is the value of lambda, the value which we are getting is 0, which is f of 0. Okay. Now we need to find out what is 4x plus 1 for 0. So limit x tends to 0, f of x will be what? It will be 4 times 0 plus 1, which will be 1. So see, no matter what is the value of lambda, it is never be going to continuous, or rather these two values are never going to be equal. So we can say that for no value of lambda, the function is continuous. Now we also need to check the function continuity at x equals to 1. So we'll check it. Okay, now we have seen that the function is not continuous for any value of lambda. Why? Since 0 is not equals to 1. We have seen that in the previous case. But what they have asked is to check the function continuity at x equals to 1. But what we have is, for x is greater than 0, the function's value will always be 4x plus 1. So in this case, if we draw a function, so when x is greater than 0, so it means from when we start over here, if we plug in the value of 0, so 4 times 0 plus 1, it will be always 1. So what it says that for any value which is greater than 0, the value of function will be 1. So what is need to check is, when x is equals to 1, we can say that this function is continuous, right? And necessarily, if you can say that the lambda value is not necessarily required for this particular function, what it means is, when you apply any value which is greater than 0, then lambda is not required. So in this case, we can say that at x equals to 1, the function is continuous, but for any real values of lambda. Check. This is sound test for 26, 27, 28, 29. Okay, now we will see the 26, 27, 28, 29th question, which basically tells you to find the value of k. Now we'll look what is the continuity, and it is defined that find the value of k such that these functions are continuous. Okay, so we have k cos of x divided by pi minus 2x. So we don't necessarily want this 2 pi minus 2x in the denominator. So what we can say is, we can plug in pi minus 2x as t. So as x is going towards pi by 2, we can say that t is going towards 0, and we can put it over here as k times cos of what will be x from this? X will be pi by 2 minus t by 2. So if you simplify this, you can find out that everything divided by t. And now you know that cos of 90 minus theta is nothing but sine of theta. So this will be k sine of t by 2 divided by t. And now we know that since x is going towards pi by 2, so t will go towards 0. Why? If you plug in pi by 2 over here, it will go towards 0. So we can say that if you divide this, which is k sine t by 2 divided by t by 2 times multiplied by 2. So you have divided and multiplied by 2. So you know that when limit t is going towards 0, these value will become 1. So what you have is k upon 2. And the function of pi by 2 is given as 3. So you just have to equate these two values, which is k upon 2 is equals to 3. So your k is 6. So you can say that at k equals to 6, your function is continuous. Now we'll check the 27th question, which says that k times x square for less than or equals to 2. So when you immediately put in the value of 2 in place of x and you equate it to these. So you have your k as 3 by 4. That's your answer. Now we'll see the 28th problem, which says for anything less than pi or equal to pi, you have k times x, which is pi plus 1, and this should be equal to cos of x. Why? Because we want to have the function as continuous. So what is cos of pi? So what is cos of pi? It is necessarily minus 1. So you have pi plus 1. So your k will be minus 2 upon pi. So in the 29th problem, we have k times x plus 1, which is basically same. So k times 5. Why? Because it is less than or equals to 5 plus 1, and we need to equate this. You understand? First you have to understand this, because these two functions are continuous. So if you plug in 5, okay, so what is k times 5 plus 1, which is equals to 15 minus 5, which is basically 10. So this is 10. So you have k as 9 over 5, 9 or 9 upon 5. Now we will take a look at the 30th question, which is 30 question on your 5.1 exercise from your Ncert book, which basically states that find the value of a and b. So we need to find the value of a and what is the value of b. So in this case, we can check that the continuity function or the continuity limit for the first two functions is 2, since f of 2 will be 5, which is given. And in case of limit x tends to 2, f of x, it will be, when you plug in 2 over here, you have 2 times a plus b. So you can now tell that these two functions are equal. So you can state your 2a plus b equals to 5 as equation number 1. And in the second case, what we know that the limits are 10. So you can plug in f of 10 is equals to 21, since it is equal to over in this function. And in case of limit x tends to 10, f of x, it will be, so you plug in 10 over here, so it is 10a plus b. So the second equation is necessarily 10a plus b. Now you just need to solve these two functions and you can have your value. So if we subtract 1 from 2, you can get my b as cancelled. So 10a minus 2a will be 8a, and 21 minus 5 is 16. So your a value is 2. So when your a value is 2, so your b will be 1. Well, how come? So 2 times 2 is 4. So you subtract 4 from 5. So you have b equals to 1. So that's your answer.